Welcome to Bite-Size Data Science. Let's revisit the Ensemble algorithms to compare the performance of a few more of these algorithms, XGBoost and LGBM. In video 72, I compared several Ensemble algorithms using two different datasets. The algorithms were decision tree, extra tree, gradient boosting, and random forest. The best performer for the Titanic data was the random forest classifier, and for the cancer detection dataset, the gradient boosting classifier took the top spot. Both XGBoost and LGBM are gradient boosting algorithms, so we would expect them to perform similarly to gradient boosting. Still, we want to make sure. XGBoost stands for Extreme Gradient Boosting, and LGBM stands for Light Gradient Boosting Machine. Let's see how these algorithms perform for two datasets. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Just like in video 72 and 74, I'm using a tool that is part of the IBM Watson Studio environment to compare the algorithms. The tool is called AutoAI. It also requires the use of Watson Machine Learning Service. The light version of the service is available for free. I've already created the AutoAI experiment, but I want to show how easy it is to do. I start with adding an AutoAI experiment. I give it a name and create it. The first step is to select the training data. I pick Select from Project and then select the Titanic data. Once the data is analyzed, I identify the target attribute. In our case, it is the column Survived. We see that, right away, AutoAI figures out it is a binary classification problem. Since I'm using AutoAI to compare specific algorithms, I need to modify the settings. First, I remove the name column from the training data since it won't add any value to the modeling. Then I go to Prediction tab and select the top two algorithms from video 72, Random Forest and Gradient Boosting. I add the two algorithms we want to test, LGBM and XGBoost. Also make sure AutoAI tries the four algorithms. After saving the settings, I'm ready to run the experiment. This would take a few minutes, so instead I'll go to the result of the run. We use 6 attributes to create a model over the Titanic data. For each model, AutoAI creates models 4 different ways using hyperparameter tuning and feature engineering. The result is 16 model pipelines. We can quickly compare the 16 pipelines by looking at the following graphical comparison. We see all the important metrics from accuracy to precision and recall. We can also look at the details for each pipeline. In the details of the top pipeline, the random forest classifier is again the best performer, and both LGBM and XGBoost perform the same as gradient boosting. We can look at different aspects of the model. Let's take a look at 2 of them. The first one is feature transformation. When creating models, we may have to create more attributes to improve our modeling. In our case here, we can see PCA and logarithmic transformations. The new features are listed in order of importance. We can go to the Feature Importance tab to see which are the attributes that had the largest impact on the decision. From the original features, we see that sex and P-class have the most impact. The breast cancer study is also a binary classification problem. The 2 top performers in video 72 were gradient boosting and extra tree. We selected these 2 algorithms in addition to XGBoost and LGBM. One obvious difference is that we have 30 attributes contributing to the model creation. In the results, we still have the gradient boosting classifier as the top performer, with LGBM and XGBoost being close. Looking at the details of the pipeline, we see the following feature transformations. The transformations use products of attributes. Looking at the feature importance, we see that all the important attributes are from the feature engineering. One more thing, AutoAI allows us to save the model as a notebook. One great way to use this capability is as a learning tool. We can see how the transformations were done and how the pipelines were assembled. We saw that XGBoost and LGBM perform slightly worse than the gradient boosting algorithm. The differences could be due to the specific datasets and their sizes. On other datasets, they could end up on top. Using tools to quickly create and compare models can save a lot of time and effort. Make sure to look into tools for your modeling. See you next time on Bite Size Data Science, and don't forget to subscribe.